Hi, welcome to my video on solving polynomial equation using synthetic division. This is part 1. The next video will be part 2. And when I'm solving polynomial equations, I always follow this order. But the polynomial equation is ax to the n plus bx to the n minus 1, cx to the n minus 2 plus, and I'll keep going down to the constant term k. The coefficients are integers a, b, c, and k, and all of them are integers. And the powers are whole numbers. So this is a whole number up here that will decrease in descending order. So if you let a equal 1, then a is 1. So there's a 1 here. So the equation becomes the same as above, only the leading coefficient is 1. And as a result of having a leading coefficient of 1, then all the factors of k are going to be the possible roots. So here's the steps that I use for solving equations, this equation here. And the steps go as the terms are on the left equal to 0, and they have to be in descending order on the left. Then I look at the highest degree, the leading term, and see the number of roots, because the degree is the number of roots. And then I look to see if there's a GCF of x. If it is, I take it out. And if there is or not, then I look to see if 1 is a root. So that means that the numerical coefficients are going to add up to give you 0, so 1 is a root. And if that works or don't work, then we look for a grouping of the terms. If there's 4 unlike terms, we do grouping, because grouping will make it easier to do. And if you have some GCF of x, or root is 1, or you can do grouping, then if it's not complete, then you can do synthetic division. And in synthetic division, you find all the possible roots, and the possible roots are all the factors of k. Then you use Descartes' rule of signs to see which one, how many positives you have, how many negatives you have, and how many possible imaginary roots you have, and it always leads up to the total. And you use synthetic division to find a root when the remainder is equal to 0. And you do synthetic again on the depressed equation to find another root when you have a remainder equal to 0. And you repeat until the depressed equation becomes a quadratic. When you get a quadratic equation, you solve the quadratic equation by factoring, completing the square or quadratic formula. And a tip that I use, when the first root is found by synthetic division, check that root again, because it could be a double root. So if you find that 2 is a root, you check 2 again. If you find 1 is a root, you check 1 again. So you could have double and triple roots. But if you don't find that other root, which whatever it is, you could end up being misled. So let's do some examples. And the example we have here, solve for x to the 4th minus x cubed plus 6x squared. So notice it has to be, all terms have to be to the left. So we move them over. Notice when I move them over, I have them in descending order. So I have it equal to 0 in descending order. And the number of roots, notice the number of roots is the highest degree. So there are 4 roots in this one, because the highest degree is 4. And do we have a GCF of x? Yes, we have an x in each term. The smallest exponent is a 2, so we take out the x squared. So x to the 4th divided by x squared is x squared. X cubed divided by x squared is x. And negative 6x squared divided by x squared is negative 6. And we factor that. X squared is x and x. And the factors of 6 are, the product is negative 6, so 6 and 1 are 3 and 2, and the sum is 1. So 6 and 1 won't give me a 1, so it's a 3 and a 2. The product is negative, sum is positive, so I have a positive 3 and a negative 2. So x squared equals 0, x plus 3 equals 0, x minus 2 equals 0, and you put an or in between them. So if x squared is 0, x is equal to 0 when you do the square root. X is equal to negative 3. X is equal to 2. So even though 0 is a root, note, because of the square, there are 2 zeros, because a quartic, degree 4, has 4 roots. So there's 2 zeros, 1 negative 3, and 1 2. And number 2, again, you can pause the video and work these out. So I still go through the same steps. I'll go through, is it in descending order? Are all terms on the left in descending order? Yes. The number of roots here are 3, because the highest exponent is 3. There's 3 roots. And is x a GCF? No. Is 1 a root? So if I add up the coefficients, 1 plus 1 is 2. Add on negative 2 is 0. So the coefficients adds up 0, so that means 1 is going to be a root of 1, 2. Notice the x is missing, so it's 0 minus 2. So when you put it in descending order to do synthetic division, you have to make sure you fill in your missing term with a 0 coefficient. Bring down your 1, multiply, 1, add, 2, multiply, 2, add, 2, multiply. You get 2, and you get a remainder of 0. That means 1 is a root. Now we have x squared plus 2x plus 2 is the first equation. And notice 1 is not a root because the coefficients don't add up to 0. So we have to go, we have a quadratic, and we have to, well, a is 1, b is 2, c is 2. So x is equal to negative b square root of b squared minus 4ac all over 2a. So that gives me b is 2, so that's a negative 2 plus or minus. B is 2, so it's 2 squared minus 4. A is 1. C is 2. So we fill it all in first. A is 1. Done. And that gives us a negative 2 plus or minus. Now we work out the inside of this. So rather than keep writing it down, 2 squared is 4. And negative 4 times 1 times 2 is a negative 8. So that's the square root of a negative 4. So the square root of 4 is 2. Because it's a negative, we have an I, all divided by 2. And the answer is negative 2 divided by 2 is negative 1. And 2 divided by 2 is 1. So we have 3 roots. So the roots are 1 and negative 1 plus I and negative 1 minus I. And up here, finish it off, the roots are 0, 2, and a negative 3, or 0, negative 3, 2, whatever way. You can put them in order. Sometimes the teachers want them in order, so you could say negative 3, 0, 2 is the order of the roots, but it makes no difference as long as you have them there. So, number 3, again, pause the video, but it's not, the variable's got to go on the left, so it's x cubed, x squared, minus 4x minus 4. So all the terms go to the left side equals 0, and I put them in descending order. Notice I have 4 terms, so in 4 terms I try to do the grouping. So rather than write it here, I'll do the grouping. So x squared comes out in the first 2. So that gives x plus 1. And a minus 4 comes out to give me x plus 1. So that means that because this binomial is the same as this one, we can do grouping. So x squared, x plus 1, minus 4 is common, so it is x plus 1. X plus 1 is the binomial, so we get x squared minus 4. So we divide x plus 1 into this expression, we get x squared. Divide x plus 1 into this expression, we get minus 4. So that means x plus 1. And this is the difference of 2 squares, so that's x and x. That's 2 and 2 plus minus equals 0. So x plus 1 equals 0. x plus 2 is equal to 0, x minus 2 is equal to 0, so x is negative 1, x is negative 2, and x is 2. And you can put an or there between them because each one of these are the roots. And notice we have x cubed, so I didn't do it. There are 3 roots to this problem because we have a cubic. And the 3 roots are, so you can finish it off, the roots are, you can say, negative 2, negative 1, and 2. Those are the roots. 3 roots that fit this one. Okay, because I have the grouping, I didn't need to say that. And notice the coefficients do not add up to x is not common, no GCF, but I did the grouping on it. And 1 is not a root because the coefficients add up to negative 6. And let's continue. Now, if you want, pause the video and work these out before I do. And so we have to have all the variables on the left side equal to 0. So we have to get rid of the brackets first. So multiply x cubed plus 4x squared minus 2x. Multiply negative 3x plus 6. And we have to put them in descending order on the left. X cubed goes first, then the 4x squared, then the plus 3x, minus 2, minus 6. So the negative 3x goes over to become positive, the plus 6 goes over to become negative, and we have x cubed plus 4x squared plus 3x minus 8 equals 0. So we have in descending order equal to 0, and now we're going to solve. So as a result, x is not a GCF, so we can't do that. And we add up the coefficients of 1 plus 4 is 5, plus 3 is 8, 8 and negative 8 is 0. Because the coefficients adds up to 0, that means 1 is a root. So we put 1 into 1, 4, 3, negative 8. Descending order, 3, 2, 1, constant, perfect. Draw a line, bring down your 1, multiply, 1, add, 5, multiply, 5, add, 8, multiply, 8, add, 0. Again, I always have a habit of circling the 0, say the remainder is 0, so that means I have a depressed equation of a quadratic. Remember, this is x cubed, x squared, x and a constant. So when you divide by x, this is 1 as a root. Remember, the factor is x plus x minus 1. So if 1 is a root, that means that x minus 1 is a factor. And because we're dividing, synthetic division, that dividing by x, so the x cubed becomes an x squared. So that's an x squared plus 5x plus 8 equals 0. And the product is 8, so 8 is 1 times 8, or 2 times 4. So notice 1 and 8 and 2 and 4 will never give you 5. So I have to do the quadratic formula. So A is 1, B is 5, and C is 8. So x is equal to negative b squared minus 4ac all over 2a. B is 5, so that's a negative 5, plus or minus. B is 5, so it's a 5 squared minus 4. A is 1. C is 8. And all over 2 times A is 2 times 1. So that gives me negative 5, plus or minus. Let's work this out. That's, instead of writing it all down, I work out to 25. And that's a negative 4 times 8 is negative 32. So that's a negative 7. So that's root 7 with an I. Square root of 7, you can't do it. And it's all over 2. So it's a negative 5 divided by 2 plus or minus root 7 over 2i. And so the roots are, again, did I do it? There are x cubed, so there are 3 roots. Got to remind me, keep reminding there are 3 roots. So the roots are, one of them is 1, and the other one is negative 5 over 2 plus root 7 over 2, and negative 5 over 2 minus root 7, that's an I, forgot the I, root 7 over 2I. Very important to have the I in there, because that's a negative number underneath root. We have imaginary roots. So there's the 3 roots. And notice it again, picking out the GCF if it's there, checking if 1 is a root, doing grouping, makes the problems come out a little bit easier. And we have another one to do, and then this one, notice it's in descending order, and we have it equal to 0, and the highest degree is 4, so we have 4 roots. Now, there's no GCF of x, and the coefficient adds up to 15, negative 16, and 4. Nope, not 0. And it's 5 terms, so we can't do grouping. So we have to do synthetic division. So that means, let's look at the possible roots. So the possible roots are plus minus. The possible roots are the factors of 6, because that's a 1. We look at the factors of 6. Factors of 6 are 1 times 6 and 2 times 3, so it's 1, 2, 3, 6. These are all the factors of 6, so these are plus minus 1, plus minus 2, plus minus 3, plus minus 6 are the possible roots. And when I have that done, I check the, what I do is I check the Descartes' rule of signs. So we look and say that's plus plus, no, plus minus, 1 change, and there's only 1 positive. Now, when I put I'm going to do a negative x into here. So when I put a negative x to the 4th power, I'll get a positive. When I put a negative x here and I cube it, I'll get a negative. Times a positive is a negative. When I put a negative x here and square it, I get a positive. Negative of a positive is negative. When I put a negative x here, negative 9 times negative x is a plus 9. And I have a negative 6. So there's 1 sign change there. No. And there's 1 there. And there's 1 there. So it's possible that I have 3 or 1 negatives, and I only have 1 positive. So if I have 1 positive, I can have 3 negatives, and that means I have 4 roots, so I can have no imaginaries, because there's 4 roots. If I have 1 positive, I can also have 1 negative, so I have 2 imaginaries, because there's 4 roots. So you have 1 positive, you can have 3 negatives, or 1 negative. So you don't know which one of these, but you do know that you do have a negative, you do have a positive, but you have to check. So what I do, I check, have that done. So there's no GCF, 1 is not a root. So now you have to decide if you're going to, you have more negatives, so you know you have a negative for sure. You could have 3 negatives. So what I do, if I say I got possible 3 negatives, I'll do a negative 1 into 1, 3, negative 1, negative 9, negative 6. Now you could take, 1 is not a root. You could do 2, and then 3, and then 6. So if you decide to do 2 first, into 1, 3, negative 1, negative 9, negative 6. You bring down your 1, you get a 2, that's a 5, that's a 10, that's a 9, that's an 18, that's a 9, 2 9s are 18, you don't get a remainder. Then you say, well, I'll try a 3. So what you're doing now, you're taking a chance that you really don't know, but your 2 didn't work, so now you're going to try 3, because you know there's 1 positive root. So you're checking what one it is. So bring down to 1, multiply 3, add 6, multiply 18, add 17, multiply gives you 51, and you notice that's a 42, so that's not going to give a remainder 0. So other integral positive root is 6. Notice the integral. So we're trying 1, 2, 3 didn't work. We're trying 6. So if there's a positive root and it's not 1, 2, 3, or 6, then the root must be irrational. Still positive, but irrational. Bring down a 1, so that gives me a 6 when I multiply. 9, 6 9s are 54. That's a 53. And you can see this is going to take off, so 6 is not going to work. So that means I tried 1, didn't add up to 0. Tried 2, 3, 6. So let's try -1. Bring down your 1. You get a -1, 2, -2, -3, 3, -6, 6. Oh, we have a remainder of 0. So 1 is a root. So since we have 1 as a root, we should try 1 again. So we try -1 again, because it's possible that -1 could be there twice. Remember, 1 is not a root up here, so 1 won't be a root in this depressed equation. So bring down the 1, multiply, -1, add 1, multiply, -1, add, -4, multiply, 4, add, -2. Nope. So there's only 1, -1. So let's try -2. We tried all the pluses. So now we try -2 in the depressed equation. Depressed equation is up here. So it's 1, 2, -3, -6. Draw a line, bring down your 1, multiply. -2, 0. Multiply, 0. Add, -3. Multiply, 6, 0. Oh, so -2 is a root. So that means we have x squared plus 0x minus 3 equals 0. And that means x squared minus 3 equals 0, because 0x is the same as 0. So x squared equals 3. Square root of x squared is plus minus the square root of 3. So x equals plus minus the root of 3. So the roots are, go back, I picked up -1. I picked up the -2, and I picked up plus or minus root 3. That's a plus root 3 and a minus root 3. Notice that's a negative, that's a negative. Notice root 3 is an irrational root, but the square root of 3 is somewhere, it's around 1, let's say 1.7. So root 3 is positive, and the negative root 3 is negative. So there's 3 negative roots and 1 positive. So you couldn't get this irrational root here until you worked it down to the quadratic. So that brings us to doing a review of solving by synthetic division. And again, I have an order of doing it, and you'll see me do that order every time, same way. If you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.